Mumps programs consist of a sequence of commands. They call them commands, although most people use the word statement interchangeably. Each command begins with a keyword, and those keywords are reserved. Set for assignment, for loop execution, if statement, conditional execution, read, write, and so forth, and we'll get a complete list later on. Now, Mumps has something quite unusual, which I don't think any other language has. It's called postconditionals. Postconditionals are attached to command words, and they are expressions which are evaluated to determine if they're true or false. If the expression is true, the arguments of the command will be executed. If the postconditional is false, then the arguments will be not executed and will skip to the next command. At some level, by the way, two of the commands, actually you can postconditional the arguments as well as the command. But anyway, for the most part, it applies to the commands. Postconditional looks like this. If we have the assignment statement set I is equal to 2, which means we're assigning the value 2 to I, but it's conditional upon if A is equal to B. Now, see, there's the sub-expression. The assignment will be made if A is equal to B. If A is not equal to B, we will skip this and move on to something else. Here's a more extensive example, and you'll see why. The reason why the postconditionals are here is because Mumps originally had a line-oriented structure completely. The scope of every command was no further than one line, and that creates a few problems. In this example here, there's a loop. It executes up to 100 times. It's going to write out elements of the global array A based on the index I. So as I goes 1, 2, 3, 4, it'll write out global array A 1, 2, 3, 4, assuming that they exist. Well, that's the problem. Do they exist? What if the array is short? What if it's not a full 100 elements in there? We want to quit the for loop. And that's what this is here. This is a statement, the quit statement, which will terminate the loop. The quit statement will terminate the loop if this postconditional is true. What does this postconditional mean? Well, it's the $data function. Functions begin with a $. The $data function is built in. It tells you whether or not a node exists. And it also tells you whether it's got data stored at it. If a node doesn't exist, $data returns a 0. If it does exist in any forms, it returns non-zero. This is the not sign, the single quote. So basically what we're doing, for a given value of I, we're testing to see if A sub I exists. If it does, the value coming back here will be non-zero, and not non-zero is false, so the quit will not execute. Follow what I'm saying there? We will do the write. So in other words, if the node exists, data will return true, not true is false, the quit won't execute. We will move on to the write. If the node doesn't exist, data will return false, 0. Not false is true, the quit will execute, we will exit the loop. Now there's something else on this line here. You'll notice that there's 2 blanks here after the quit. After the postconditional for the quit. There are 2 blanks. These are required. If a command has no arguments, and if there is another command on the same line, you've got to have at least 2 blanks after it. If you don't, you're in trouble. The blanks, again, are very significant. So since quit never takes any arguments, either quits or it doesn't quit, it will always, if there's something else in the line, the quit will always have 2 blanks after it. If there's nothing else in the line, well, the line just ends. So this thing here will go through attempting to print up to 100, but prematurely terminating if it runs out of elements to terminate. The problem is here is we couldn't use an if statement. The logical thing is let's put an if statement there and ask if it exists, if it doesn't. Well, this is what it would look like, and it wouldn't work. So if we come along, there's the loop for I equals 1 by 100. If not $data quit. Doesn't that make sense? And there is an else statement. There's the 2 blanks, by the way, after the quit, so that's legal. Then there's an else statement. Since else doesn't take any arguments, is also 2 blanks after it. But it doesn't work that way. The scope of the if is the remainder of the line. So if the if is true, the entire remainder of the line is executed. If the if is false, the entire remainder of the line is skipped. So in the case where there is an element of the a sub I exists in the global array, and $data returns true, and not true is false, the if statement will have a false argument. It will not execute the remainder of the line. Nothing. The else does not override that. Else is an independent statement. We'll see that later. It is not actually connected to this if. It means something totally different. So one of the reasons why they put the postconditional is so you could do something like this. You could put basically a small if to determine whether or not the quit would execute or not, and still have things remaining on the line. In this case here, the only thing that happens in the first example is that if the node exists, the result of this expression is false, and the quit does not execute. The write will. In this situation here, if the node exists, and this returns true, and the not of true is false, we won't execute the quit. But we won't execute anything else in the line either, because these statements, the if statement has line scope. It's the remainder of the line. And that's important. So that's what the reason, what's one of the important reasons why postconditionals were put in, so that you could to handle the line scope. It's unusual, it's different, but nowadays there's a way around that. You will still see this, of course, but there's another way around that will avoid it. The else, it's important to note, does not is not connected to any particular. You can have an else just sitting there by itself with no immediately preceding if. We'll explain that later, but just it is. Operator precedence. There isn't any. All operators are equal. You parse them from left to right unless there's parentheses. So if I have something like this, A is less than 10 and B is greater than 20, you would expect that if A is less than 10 and if B is greater than 20, then it's true. Not true. What it really means, you test if A is less than 10, and that'll be either true or false, 0 or 1. And then you will and the 0 or 1 with B. The remainder of it is whatever this value evaluates to, it's going to be a 0 or 1. And then you're going to perform the and operation with whatever's in B. And that's going to give you 0 or 1. And you're going to ask the question, is 0 or 1 greater than 20? The answer is always no. So the evaluation of this expression is always false. Okay? What you meant was this, with the embedded parentheses. First of all, you want to do is the A less than B? This is what you actually get with that. What you really wanted was this. Okay? This one here is the parenthesization of what you get without parentheses. This is what it would mean. However, what you really need is this. You parenthesize the two sub-expressions, and then it will and the two of them together. Okay? No precedence. This has consequences. Be careful of things like this. Compound expressions don't work the way you think they're going to. Also, it means that plus and minus and multiply and divide are all at the same level. None of them is higher than the other. The basic operators, these are the operators, are, first of all, you've got assignment. That's an error. That should be negative. Not a unary operator. That should be the minus sign, and this should be the unary negative. I'll have to correct that. So that's supposed to be a minus sign. That's unary minus or unary negative. Unary plus, as we saw earlier, only it doesn't really do anything. But if it's applied to a string, it'll force a numeric interpretation on the string. The result will be whatever the numeric interpretation is. So if you had plus onto a string, quote, 111 ABC, the result would be 111. It forces a numeric interpretation. Binary arithmetic. The binary arithmetic is as what you would expect, addition, subtraction, multiplication, and division. We have two division operators, full division and integer division. In the full division, you will get the result with fractional parts. In the integer division, you will get the integer value, not rounded. It'll be floored. That's integer division. There's also modulo, giving you the remainder after dividing the first operand by the second one. Then this exponentiation, that was added to the standard somewhat later, and it raises the first argument to the power of the second. The arithmetic relational, these are technically used only with numbers, not with strings. Greater than, less than, not greater than, and not less than. Okay, we don't have greater than or equal or less than or equal. Instead, we have not greater than and not less than. I don't know why they came up with that, but they did. It's different. Concatenate, it's the underscore. You have two strings, two variables containing strings, or two constants, string constants, or numbers, because numbers are strings too, and you can concatenate them together with the underscore. The string relational operators, these are the ones that compare strings. There's equals, contains. Does the left operand contain the contents of the right operand? Follows, does the left follow alphabetically in the collating sequence the right operand? Pattern match. The pattern match allows you to compare. The first operand is the source string, the second is the pattern. It allows you to apply a pattern to a string and determine whether or not the string follows that pattern. We'll see an example down below. There's not pattern, there's not equals, there's not follows, not contains, not follows. There's also sorts after. There's a missing bracket here, I'm sorry. And not sorts after. They have to do with the collating sequence. And they're kind of obscure operators. I'm not going to dwell on them. Okay, the pattern match codes that they put in on the original version of Mumps, these are the codes. A stands for the entire upper and lowercase alphabet, C for the control characters, E for any of the 128 ASCII characters, the entire ASCII universe, lowercase, numerics, punctuation, uppercase, and a literal string. So if I have something that looks like a social security number, 123-45-6789, we could determine if some variable A, there's our variable A up there, if it looks like a social security number. It will contain 3 numerics, 1 string of a hyphen, 2 numerics, 1 string of a hyphen, and 4 numerics. If it does, we'll write OK, and in this case it would. The not pattern, which is just the not sign or the single quote in first, it wouldn't write anything because that's not true. We also have the dot operator. So if I have, if the string, the variable contains Jones, comma, J period, L period, we could say, does it consist of some number of alphabetics followed by 1 comma, followed by some number of alphabetics? Okay, so that is the 0 or more is what the dot means, and the inverse of that. The logical operators are and, or, and not. And is the ampersand, or is the exclamation point. Okay, this can be confusing for people who do C, where not is the exclamation point. Here it's an or. Exclamation point means or, not means not. And or are binary operators, logical, and the not is a unary operator. So we get, these are the truth tables, which probably not a word. 1 and 1 is 1, 2 and 1 is 1, 1 and 0 is 0. 1 and 0 less than 1, how does that work? Well, 1 and 0 is false, therefore 0, and 0 is less than 1, so that would actually give you 1. There's our precedence issue again. So we'll move on. You can look at those at your leisure. The indirection operator, this is another weird operator that most other languages don't have. There's also a command, an indirection command as well, called execute. What it does is it causes the string it applies to, it's a unary operator, causes the string it applies to be executed. So if I have a string consisting of 2 plus 2, that's just a character string, and I say write at A, then it will evaluate the contents of A and write them out in the case of 4. Now I should explain here a little bit about the write statement. The exclamation point here isn't the or operator. It indicates in a write statement the exclamation point means new line. Sorry for the confusion, but that's the way it is. Exclamation point in a read or write statement by itself, as an argument, means new line. Here is here's a short string. If I delete any previous elements of the global array X, global array X disappears. And so there's no global array X at this point. If I set X sub 1, global array X sub 1 to 99, 5 to 999, if I set V is equal to the string up arrow X sub parenthesis Y, okay, that looks like an expression, but in actual fact it's just it's a string. If I set the actual variable Y equal to 1, and if I say X is equal to $ order at V. Well, the at V will evaluate. It'll take the value of V, which is up arrow X sub Y. It'll insert the value of Y, so it becomes up arrow X sub 1, and that's what is passed to the order command. And what that does is the order command, it gives you the next index higher than the current index. So the value here would be 5. And I write out 5. Okay, do you get that? The equivalent, what that works out to is up arrow X sub 1. And that's what's passed to order. Order then evaluates that and gives you the next ascendant index relative to 1. Since we know those are the only two things in the global array, because we destroyed anything that may have previously existed with the kill, the value coming back from order, which is placed into X, is 5. When I write it out, I get 5. Again, here is a more complicated example. We set V1 equal to, quote, up arrow X. And then we ask the order of at, and then we have a sub-expression here. We have an expression. V1, the value of V1 is up arrow X, concatenated with a parentheses, concatenated with the value of Y, concatenated with a closed parentheses. All that together evaluates out to be up arrow X sub 1. And when we get it back again, we're going to get 5 because it gives you the next descendant. But that's a longer use of the indirection operator. We'll see that in some of the examples. A complete list of the commands. Break suspends execution or exits a block. That's non-standard, but I use it that way. The break is going to be very implementation dependent as to what it exactly means. It was originally intended in interpreters to pause the interpreter and then go back to command line mode so you could print out variables, change variables, examine what's going on in the structure of the program, and then start the program up again. Close closes an I/O file, an input-output file. Database, this is non-standard, sets up a global array database. We won't worry about that. That's in my version, not in others. Do executes a program, a section of code, or a block. Depends upon what follows the do as to what it's going to execute. It can actually execute a remote program, a local block of code, or a block of code that's on disk. The else is a conditional execution. It's based on the value of a system variable called $test. If $test is false, what follows the else will execute. If $test is true, the remainder of the line is skipped. We'll see that again in a little bit for real examples. For is the iterative command. We'll see a lot of examples. Goto is the goto. It transfers control to another label in the program. Halt terminates execution. Halts your program. Hang, which is similar to it, they have similar abbreviations. H means halt. H followed by a number with an argument means hang. Hang suspends execution for a certain period of time. HTML is non-standard. I won't talk about the if is the conditional. It determines, depending upon what the value of the expression is, it will or will not execute the remainder of the line. Job creates an independent process. It's basically a fork. It forks off an independent process. Lock is used to control access to the database. It doesn't actually forbid access. It just posts that some things you shouldn't do. We'll see the lock. It's kind of not all that important nowadays if you're using a relational database to store your globals. Kill deletes a local or global variable or tree or a subtree. Merge copies two arrays, merges two arrays into one or a third. New creates new copies of local variables. Open obtains ownership of a device, a file usually. It's the opposite of close. Quit ends a for loop or exits a block. It's an exit for a block that's invoked by a for or by a for loop itself. Read reads input. Set is assignment. Shell is an extension. I won't get into it. SQL is an extension. Tcommit, tstart, restart, and trollback were these were suggested into the standard, and they may or may not be in a given version of Mumps. They were never actually approved as parts of the standard, but they have to do with transaction processing, which are databases, integral transaction sequences, and that's how you do it. We probably won't get into it here because that's very much more implementation specific. Use tells the system which device or file to read or write to. And you change that from time to time. View is implementation defined. It was used for debugging. Execute allows you to dynamically execute an entire string. It's similar to the indirection operator. And then anything beginning with Z is implementation defined.